Okay, welcome. So we had to prove in the previous video that tan theta equals sine theta over cos theta. So in this video we're going to prove that sine squared theta plus cos squared theta equals 1, and this is based on pretty much what we worked out up here. So what you've got this, to clarify it, people forget that sine squared theta is the same as sine theta squared, okay, which is also the same as sine theta times sine theta. Okay, in which case we worked out that sine theta was y over r. Okay, so therefore you can do y over r squared. Okay, so we can just plug that in. Same with cos theta, and we found that cos theta was x over, I should just point out, was x over r. So then you can just plug that in, x over r, and that's squared, and that equals 1. So we just need to show how and why. So essentially what we can do is say that y squared plus x squared is over r. So we can just do that because we should know with our fraction work that you can do that when you're multiplying and subtracting. So what you want to do, don't forget the squared, okay, and that's essential. So let's take r squared out of this equation. Okay, so you're going to get 1 over r squared, and that's going to be multiplied by the x squared. Okay, I hope you can see that you're able to do that, because if you were to expand these brackets, you'd end up with this. Okay, so whenever you see an r squared or an r, that means it's the same as timed in by a half. So you can have, like, for example, a half times a plus b, okay, is the same as over half. Okay, there's a, you can imagine a 1 there if you like. That makes it easier. So we'll leave that. Alright, so what have we got? How does this help? Does this help in any way? Well, what you have to recognise now, well, you wouldn't have recognised it, but if we go all the way back up, okay, we've got to use the equation of a circle here. So the equation of a circle you get by using Pythagoras, and so Pythagoras, as we know, was a squared plus b squared equals c squared. Okay, so that's just, in this case it's going to be x squared plus y squared equals r squared. Okay, so r squared plus y squared equals r squared. Let's go down, and we see that we have a y squared plus x squared, and we know that that equals r. Okay, so that means we go across here, we can say that we've got r squared times r squared, because we just found out that that equals r squared. Okay, and now it's just a case of, well, what can we do with this baby? So that's just r squared divided by r squared, because we're now sort of, if you like, multiplying out the bracket, so you end up with this, and then you can just basically cancel, and then you end up with 1. So therefore we've proved that this thing equals 1. And now I'm out of breath, so we'll leave it there, and you can have a look. I'd like some feedback to see kind of which bits I didn't quite explain fully. And we're going to sort of. So this is a. I just want to make a point that this is an important identity that's used a lot, and so is this. There are others, but these two are pretty fundamental. So if you can, you can either try and remember how we derived these things by doing all this, or you can just remember these here. And so we'll see how it'll be used in this sort of following series. So look forward to seeing you there.